In this video, I'd like to continue the series on a math question each day, and this day is January 16th, 2023. And for this problem, we need to know why, when we add two fractions, do we need a common denominator? Or why do you need a common denominator when adding fractions? And the prerequisites needed for this are just the basics of pre-algebra. And if you've gone through grade school math, and this is something you should be able to answer if you learned it properly, but like I said, this problem tends to be a little bit difficult. Many people know how to add fractions, they know how to find a common denominator, but when asked the question of why they need it, that's where a lot of students will get stuck. So even though you really only need fraction arithmetic for this, which is something you might learn in 4th or 5th grade, give or take a couple years, this question might be very difficult. And at this point, I encourage you pause the video, think about this as best you can, give it at least a few minutes, and then whether or not you find the solution, go ahead and unpause the video, and then we can go through this together. And at this point, I will assume you've given this a try, so let's consider this problem now. Why do we need a common denominator when adding fractions? And just as a review, let's look at a simple example, 1/2 plus 1/3. When we're adding these fractions, we don't have a common denominator. So our first step will be to find a common denominator. And we can always do that by just multiplying the two denominators together. Sometimes there are simpler methods or simpler denominators we can use, but that will always work. So if we multiply the top and bottom of this fraction by 3, we are essentially just multiplying by 1, which doesn't change the value of the fraction. We can get a denominator of 6. This will give us 3/6 for this fraction. And for this one, if we multiply top and bottom by 2, again, we are just multiplying by 1. We're not changing the value of this. We get 2/6. And you can see that these fractions are equivalent to their original fraction, since if you re-simplified these, you would get back what you started with. And then once we find the common denominator, we just add straight across and we get 5/6. And like I mentioned, many students do know how to do this process, but when asked why we need to do this, why do we just add straight across the top and we don't add across the bottom? This is where a lot of students will be stumped. Since when multiplying two fractions, let's say 2/3 multiplied by 1/2, in this case, we do just multiply straight across. We get 2/6, which is 1/3. And that's another question you can ask. Why is this different than adding fractions? Why don't we need a common denominator here? And basically, these questions are incredibly important to ask, because if you don't know the answers to these questions, then that essentially will prove to you that you're memorizing the techniques rather than understanding it. And these techniques can be a little bit difficult to understand, but once you see the explanations, they really do make sense. And in general, everything in math makes sense. So if it's something that you don't fully understand why, then assume that there is an explanation, you just haven't learned it yet. So with this problem, what we can do is re-evaluate this using a more visual method. And we can evaluate this using, let's say, the circle model or a rectangular model. It doesn't matter. But this fraction 1/2, let me change colors. We can use a circular model, and same for 1/3. And so we're going to be adding these two fractions, but we need to rewrite 1/2 in terms of this circular model. And essentially, the denominator tells us how many times we need to split up this circle, or how many equal pieces we need to have. And in this case, we need 2 equal pieces. So we will split this exactly in half. And then the numerator just tells us how many of those pieces we actually have. So this picture right here, you can think of as a pizza or a pie, and we cut it in half, and then we have one of those halves. So this right here is a representative model of the fraction 1/2. And if we carry out the same process for 1/3, we can split this circle or this pizza or pie into 3 equal pieces. And I recommend starting at the center and then doing your best to split this evenly. It's often hard to do this by hand. But again, the denominator tells us how many equal pieces we split this into, and the numerator is how many we actually have. And at this point, you can see we're adding these two fractions, but you might notice the issue. This piece right here and this piece right here, how could we add those? They're not the same size. They are different sized pieces. So if we did add them together, we have 2 of these pieces, but they're not the same size. So it's not really meaningful to say we have 2 of them. What would be useful is to redivide our circles or our pizzas or pies into the same amount of pieces, and then we can just count up how many we have. And that's the process of finding that common denominator. Essentially, that common denominator just splits up your fractions so that they are all the same size pieces, and then we can just count up how many of those pieces we have. And with this fraction, if we split this into 6 and this one as well, then each of these pizzas or pies or circle models would have 6 pieces. And again, we could just add up those pieces. And we know 6 would work because we can just multiply the 2 denominators together. That will always give us something that works. So on this left circle here, we can split this into 6 total pieces. And again, I'm not going to draw this perfectly, but it'll give us a rough idea. And for this circle here, we essentially need to take each of our pieces and then just split it into half. And now we can count up how many total pieces we have, because notice that each of these pieces now is the same size, or at least it's supposed to be the same size. These drawings are not completely perfect, but we can count. We have 3 of them over here, and we have 2 of them over here. So in total, we have 5 of these pieces that come from a circle cut into 6 equal pieces. And that's exactly what this fraction here represents. If we move these 3 pieces over here, then we would have our 5/6. So we find a common denominator just so that the objects that we're adding together are actually the same size, and it makes sense to add them together.